are, like that's a small grinder versus a larger grinder. This is 15 amps. That's pretty heavy. I mean, you really got to do it. You know, you got to hold it, and there's a guard, so keep the guard on. Like this, you can almost like hold with one hand, but definitely eyewear. This is loud, so eyewear and ear protection.
Perhaps be outside.
Yeah.
Oh man, then we'll miss all those beautiful inside shots. But no, it can be
Take
outside.
a photo from outside in, and then
Yeah.
you'll get it.
Yeah.
We're gonna fit these on CNC during the flurry.
We can. That's actually a cool thing. Like, we talk about the CNC flurry, just mounting this and having, like, for example, if you do this to a lathe chuck, which is effectively our rotors, our rotors that we're making are big lathes already, and you drive that with precision. But think about this: if this moves like that, you just made yourself a screw or like an auger for the.
Yeah, well, it's very
Yeah, so you hold this along a shaft that's spinning, that gets you a screw, very precise screw. If you go in, that's like a screw has different diameter. That's used in things like the extruders. So that would be pretty cool. Like Joshua Pierce, formerly of Michigan Tech, he's working on that kind of a lathe, a CNC lathe for making screws for 3D printer extruders. So there's also other prior art. This thing. And these kinds of things, they can injure you quite bad. This is like 3,000 RPM, and
The
50
cutting
amps.
wheels can shatter.
Yeah, they
Is-
can
yeah.
The worst thing is like you get this like in a crack somewhere, and it logs and just throws you and shatters and stuff. And
Yeah.
but definitely gloves with this. Like if you get cut on that, like you'll probably protect yourself. Otherwise, you got a bad cut or flying body parts. Yeah. So really treat these with respect. I mean, this one too. I mean, the fast spinning blade. It's like 5,000 RPM, so it's super fast. I mean, this.
That's crooked too, the blade.
No, the guard is crooked.
Oh.
But good eyes, honestly.
If the thing is vibrating or like it's making a lot of noise, like
Turn it
don't
off.
use it. There might be like a broken gear.
Make sure the chuck is nice and tight.
Oh yeah.
Well, like if the wheel flies off, actually that's not too bad because so it's self-tightening, but the thing is, like if it's loose, that means it's probably not driving the wheel too much. So when it pops off, it kind of just like dribbles off instead of like shooting off somewhere.
I don't know.
Well, it's also.
Well, with the
I don't
guard,
know. I don't know.
I
the
mean,
guard, I'm not sure.
The nut
If-
it's self-tightening, like
It's
that's
self-tightening.
the direction that it's spinning
Okay.
will drive the nut on.
So it loses its torque while it's falling off.
That
So
was my idea when I was talking about flurry.
these get worn out. There's
Just
just real quick, but these are more blades.
Yeah, like a Jaguar.
All kinds of this.
Gazillion.
It's got knock-on tires.
The tool you need for that is one of these. The thing with the two holes in it. So what you do is put that on. Put that on, and there's different sizes of these. You gotta hold this button here so it locks. It actually locks. Otherwise, you'd be just spinning. So I'm holding that button, and then which way do we?
Left go loosey, righty tighty.
Well, it would be opposite of that. So
It's reverse threaded.
It should be reverse thread.
Depends on which
so-
direction
no,
it
but it's-
spins.
But here,
Well,
it's kind of
it's a
clockwise
camera
to loosen the knot.
from the
It's
top,
easy
I
by
believe.
hand. So I'm gonna tighten it back down, but yeah,
I should
those
know.
things are back there, and we got a bunch of these
Yeah.
grinding wheels.
Who knows?
Similar here, this is, once again, you gotta hold that button there. So you get to a place where it locks. There it locks, you can feel it. You gotta press this, maybe without gloves, but yeah, and then you do that. So that's the locking button there. Guard, yeah, you definitely use a guard on this. If it doesn't have a guard, don't put a guard on it. Thank you. What else? So then there's welders, which we'll do. The welder, see for the welder, what we'll do as the basic exercise, like what you want to do is understand, you'll see it, but I mean, you'll understand like how the metal deposits, like, so that you watch the puddle, like a lot of people say watch the puddle, the molten stuff that remains after. But let's do this exercise. and actually like keep saving it for future generations, as in like the next person works on that same artifact. But you get a piece of plate, and I have this thing somewhere here, maybe I'll find it right here. Start. A lot of information.
Good. Good thing we're recording.
Oh, here's our tubes.
Can you record and everything?
Right here.
Because that gets sound too.
Yeah.
Your camera.
There's an experiment in light art additive
Hello.
manufacturing happening. So get a plate and then just
But this is very
do a
subtle, I
square
mean, I
or even a round thing.
didn't
Put
catch
two
it while you
squares
were recording.
and keep building it up till you print a tube in 3D. So practice wire arc additive manufacturing. That's a way for you to understand how the welder deposits and how it melts the metal below. And we typically do pretty much like, we weld a lot of 1/2 inch, typically set it on like setting 4 on a welder. That's it, like don't worry about the settings. Like people tell you like, oh yeah, high side, low side. We just do 1/2 inch and 4. That's like industry standard. That's actually form. And that will help you, that will help you understand like, well, you can learn each setting because you'll see that some settings you'll be like, you don't understand how to deposit. Start with that, like high side 4. Learn that for the wire arc additive manufacturing thing. And then like by the end of this, it'll be, you know, a usable artifact. It'll be a hay bale. Well, think about it. You can keep adding to it. You can add to the sides of it, so you can make it to like whatever shape. But that's how it works. It's additive manufacturing there, and it'll keep. So I started a thing like I did it for like 5 minutes, and I, you know, kept doing this. But if you can do that, where you're actually building something up, then you understand welding, because you'll know that how to.
Because if you're too close, it will start
Melting it.
decomposing too much. It'll
Yeah.
melt too much.
Yep.
If you're too high, your bond is not good.
Yeah, you'll be like
Sputtering.
it'll be like sputtering and
Sputtering, yep.
stuff. That's actually a cool thing to do. And then, if you understand that, then to join 2 pieces of metal, I think you'll understand how to do that. But the thing is, you got to melt both things. You got to be careful. The only thing you got to be careful about is like when you're welding, yeah, and it looks like it welds, but it's just like so superficial. So you got to really melt the one into the other. With 1/2 inch steel, it's pretty easy. On the high setting, like 4 is pretty high, 6 is the max, but 4 is pretty good. Like 4 and 5 is what we like around here.
Is it better to push or pull?
If you're going, I would say pull. I don't even know what that means.
You can be going, yeah, in front of, leaving the puddle behind, or
I think it depends on your orientation.
Yeah.
Just
Well, I would
piece.
go like pulling. Yeah, I would go pull, because like if you're
you can see the
pushing,
work you're leaving behind.
Yeah.
I typically go. Why? Because all that heat from there, you're like heating up your nozzle too much. I would just go the other way, so you're moving away from the heat, because you're actually for longer welds.
Yeah.
It's like you're heating up your gun too much.
Uh-huh.
So for that reason, I would pull
Okay.
away from the heat. Yeah.
And
So-
we're also using a different drill for these, right? Than the mag drill.
Yeah, we're doing a
Different bits.
different bit, a solid bit. Which we
Okay,
got
but
back.
same drill. Okay.
Yeah.
Same drill. So this drill's got, you guys have seen the chuck replacement and all that. Watch out for the key inside the chuck, that stuff. But yeah, I think we have a bunch of 3/4. So like all our bolt system
it's
back
that
there,
way.
it's like all 1
This
inch
is
and a
the one
half
that
inch
takes
and
the plug
3/4 and
and
a half
stuff.
inch. So
I
it's
noticed
like
that yesterday, I was looking
that's
for
fine.
something else, and I was like, it's all holding phone.
Well, yeah, because these that will help a lot, because you'll be like, those bolts have to be pretty precise. So it's like if you're looking for an 11/16, it's like the store might not even have that. Like otherwise, you can go to any store and they will have it. Like 11/16, I don't think you'll find it at Menards, whereas you have 1/2 and 3/4 at Menards or 5/8. So yeah, like the 16s, that's like really weird. Okay,
Okay. Anything
so
else?
plenty of stuff. Any questions?
Ready, steady, go.
You want to break up into
Oh, so
teams, put
talking about
one-person
3D printers,
experience?
just like for the flow, we'll take apart that house in a week or two because we're really busy on a tractor. But for now, 5 p.m., I would suggest, like, if we're working hard, then you probably might appreciate finishing up your printer. Like, so I would like to propose that we quit, so today is the weekend, quit at 5 and work the rest of the day on a printer, because we'll still have enough daylight today to get tired.
Yeah.
So we could get one, last night we got one going, got another one today, and another, and another. So,